Hopefully everyone in a good condition and all sihat, insyaAllah. Mudah-mudahan we get something useful information tonight. Amin. Okay, so now we begin with our slide. Okay, I will, at the end of this lecture, I will put some exercise which we can identify what is the H null, what is the if we get the significant result, varieties of significant result, how can we conclude our study? Okay, then let us finish our slide first. Okay. Okay, this is Twoway Factorial ANOVA. Okay. And I will also share my R. Okay. Then we go for the slide first. Okay. In this Twoway Factorial ANOVA, subject are assigned. Okay. Actually, what we are doing at this stage, which is all the R, all the exercise, all the example that I give to you on the slide, it based on the a few slides at the beginning, which is the last class, which is the first that we learn about term, that we learn about within group, between group, then we learn about what is ANOVA, MANOVA, ANCOVA, and how to create a formula. All of that information we will demonstrate throughout the slide. Okay. Now, this the topic, which is two-way factorial ANOVA. Okay. For this two-way factorial ANOVA, we know that for two-way factorial ANOVA, we have two factors. Okay, now we can determine here. Here is our case, which is in two-way factorial ANOVA, subject are assigned, okay, this case, subject are assigned to group that are formed from the cross classification of two factors. We have two factors here. Then this example, okay, for this exercise, we use the dataset tools groups. Okay, this dataset are based installation to demonstrate a two-way between group ANOVA. Okay, this is the case, which is we are going this dataset to demonstrate this two-way between group ANOVA. Okay, then in this example and this dataset, we have to really clear what is data all about. In this data set, we have 60 guinea pigs are randomly assigned to receive one of three levels of ascorbic acid, which is three level, different level, 0.5, 1, and 2 milligram. And this is one factor. And another one is there are two delivery method, which is whether they'll give to the guinea pigs orange juice or vitamin C. Okay. Then under the restriction that each treatment combination has 10 guinea pigs. Okay. Then each treatment has 10 combination treatment combination of guinea pigs. Then here our dependent variable is dose length, which means in our formula, when we create in R, A or V, inside the bracket, which is this is dose length. In our R letter, you will see LEN length. They define it as a dose length as a length. Then this lambda, okay, this is the factor that we want to observe. This is the formula that you have to create. What factor that you want to see their impact, which is you want to look at the difference between the level of ascorbic acid, or we want to see the difference between orange juice and vitamin C. Depend on us. Okay, now, okay, is it clear? That's what we were going to do in R after this. Okay, the following listing of code. Okay, now look at your R and open back my lab exercise using R previously. Okay, let's begin. Okay, now here first thing that you have to remember, no need to remember, in the first slide they mentioned that in this analysis of variance you have to use library HH, GPplot, RRPOP, MP outlier and CAR. Okay, I have question. How can we remember what package that we are going to use? Okay, this is actually when you do statistic, and for this class the lecturer will state which library that we are going to use. Like we learn about C++, what library that we are going to use it, it's something like that. If you don't call that particular library, so we can't use the function from that particular library. So this library had already mentioned in the first slide on the previous lecture. And if you get some error, maybe you don't call this library yet. Okay, is it okay before we do these two screws? Okay, so let's start. Mm, Just run the code. Okay, now we are here. Okay, now we are here. And just run it. We are attached to schools dataset. Then the table for supplement and dose. Okay, this is the dose, which is 0.5, 1, and 2. Different level for dose. And this is the supplement type, which is orange juice and vitamin C. Okay, can you see my R now? Okay, now we can see this group assigned to the different dose level and different supplement type. Okay, so this is 2 factorial that we are going to study. Okay, now this is aggregate. Okay, we can see the summary of this supplement and dose in terms of mean. Okay, then we use function aggregate. Okay, for this you can see that, okay, this is the mean. Okay, then we run. Another one is, this is the standard deviation. If you want to find the standard deviation, and if you want to look at our data for the two scores, we can see the first 6 data for the two scores look like. Okay, this is the first, which is, this is the length, tooth length, and this is supplement, and this is the dose that it take. Okay, then when you want to view two screws, okay, here no need to call view. Okay, when we run it, okay, this is error because we want to, if you want to view two screws, no need to view. Okay, just put two screws, then the data set of two screws will be displayed for you. Okay, this is the data set for two screws. Okay, so then this is the analysis of variance based on supplement, dose, and interaction between these two. Remember back, this is the formula. And from this formula, we get the factor, which is the significance of supplement, dose, and in relation with these two. Refer back to the how to create a formula. Okay. Any question on that? Okay, when we want to view what is analysis of variance that we get from this fit, just put summary fit. Okay, so we can see that, okay, this 3 star, meaning that it close to between 0 and 0.001. And this is 3 star also, this between this point, which is between 0 and 0.001. And this is also star for the in relation between supplement and dose. Okay, what can we get from this result? Okay, let us uh, look. Okay, now in terms of group distribution. Okay, now from this we notice that the table here, the data is balanced. The design of our study is balanced because there's equal sample size in each design, and the aggregate provide the same mean and standard deviation. Okay, this is the aggregate. We find the mean and the standard deviation of our data. And the ANOVA table provided by summary just now. Okay, function indicate that both main factor, supplement and dose, and the interaction between these factors are significant. Okay, meaning that this supplement dose, okay, supplement dose and relation between this, it is significant, which is reject H null. And we can say that there is different factor, which is different level give a different length of two screws. Okay, are you good? Okay, then. Mhm. Uh, then we want to see the if there is this is the analysis. If you want to see the interaction, we can visualize it with, by using interaction plot. Okay, by using this interaction plot, okay, to display the interaction between two-way ANOVA. Okay, this is the code for the how to visualize, which is we are using the blue and red color for this, and we run it. Okay, and this is the graph. Okay, and this is supplement, which is supplement, and this is the dose. Okay, the blue is the for the supplement. Can't find the, okay, we can see the supplement, the lowest one of the supplement is what? The legend here. Okay, here. Interaction. Dose supplement and okay. Column C, dose supplement length type B interaction plot. Okay, then you can see here, which mean okay, this is the length just now for 4.2 vitamin C, 0.5 vitamin C. Okay, this is the mean, the mean. Yeah. Okay, we can see from the mean aggregate data just now. Orange juice and vitamin C for 0.5. We can see that the highest one is for orange juice. Okay, means that this legend, the red one is for the orange juice, and the lowest one here from vitamin C based on the mean of length of their teeth two schools. Okay. Okay, this is one way how to show the interaction between this factor. Okay, now the second one. Okay, uh, okay, now with a little fitness, you can get an interaction plot of the plot mean by using the plot mean in the G plot function. you can see the little fitness, which is if we run this, okay, this is the gplot library, and we can use this library to use the plot mean. Okay, and we can see this kind of graph that we get. Okay, here, from this kind of graph, okay, we can see here, okay, this is, okay, it quite detailed because, okay, there is orange juice, vitamin C, okay, this is for 0.5, and this is for N10, okay. In this graph, include the mean as well as error bar, 95% confidence interval, and sample size. We have this sample size. Okay, finally, you can use the interaction, another function in the HH package to produce a plot for both main effect or two-way interaction for any factorial result of any order. Okay, now we are going to show our graph in many way. Okay, which is we have this is one way how to do the interaction plot. Just now another way, and if you want to visualize it once, which is we want to visualize it one time serentak, then we can use this library HH. Okay, and this is interaction to WT is from this library package HH. Then we want to see the supplement those interaction. Okay. Okay, from here we can see this the plot that we get. Okay. And this is for different dose, and this is the graph that we have in terms of the dose length, and this is for the dose plot. Okay, for different level of dose. Okay, this is box plot for to show the length. Okay, from the different level of dose, and this is by using the different supplement. Okay, and this is the interaction between the two supplement in terms of dose, interaction between dose and supplement. Okay, we can plot it by using this the effect, the main effect in the two-way interaction. Okay, this is how to visualize our result. Okay, then here, can we continue? Okay, now we go for our slide, slide 60. Okay, what is repeated measure? Remember back our example in therapy of anxiety. Okay, repeated measure meaning that in that case, which is we have therapy CBR within group, we do it for 10%, sample 1, sample 2, until sample 10. The repeated measure meaning that we do it for 5 weeks to measure the effectiveness of this therapy, and then we repeat it again for 6 months. Okay, this is we repeat the same measurement after 6 months. Okay, this is what we call repeated measure. The slide for repeated measure in the first the beginning slide last week. Okay, this is the exercise with example by using the repeated measure. Okay, this is two-way factorial that we show just now, and this is the result, and this is how to visualize the interaction, and this is how to do the to visualize main effect and two-way interaction. Okay, this is okay repeated measure ANOVA. In repeated measure ANOVA, subject are measure more than once. Okay, this is what I mentioned just now. By using the same therapy exercise, which is the same therapy procedure, we measure it 5 weeks, then we repeat it again 6 months. Okay, more than once measurement that we use. Okay, this section focus on repeated measure ANOVA with one within group and another one is between group. Okay, this is the between group is a common design. Between group because just now the example that I give to you, we have 10 people that going to do the same therapy, but we use in the two different time. Okay, that is the between group factor. Okay, and well, we will take our example from field of psychology, ecology, and this psychology, ecology study how the psychological and biochemical process of living system respond to variation and environmental factor, a crucial area of study given the realities of global warming. Okay, this is our domain for this repeated measure ANOVA. Okay. Then here we have carbon dioxide data sets, include CO2 data set. Here included in the base installation content the result of study of cold tolerance in northern and southern plant of the grass species. Okay, by a Echinocolia cruscali. This is the grass species, and this research from Portville, Lechovis, and Tardif 1990. The photosynthetic rate of chill plant were compared with the photosynthetic rate of non-chill plant at several ambient carbon dioxide concentration. Okay, then half of the plant were from Quebec and half of them are from Mississippi. Okay, this is our how they set up their research. Okay, then here in this example we will focus on chill plant. The dependent variable is carbon dioxide uptake, and this is the unit for that. And the independent variable are type Quebec versus Mississippi and ambient carbon dioxide concentration. This is ambient carbon dioxide concentration. They showed it as CONC with seven level, which is they range it from 95 to 1000. Okay, type is between group factor, and this concentration is within group factor. Okay, this is one type is between and another type is within group factor. Okay, this is the factor for within group, and this is type just now, which is type of okay, with 7 level level. Okay, this is between group factor. The analysis is present in the next listing. Okay, now we will do this in R. Okay, remember our dependent variable is carbon dioxide uptake. We want to know from the factor, is there any give different for this dependent variable? Okay, now let us do it in R. Okay, this is what we are defined WLBL. W1B1 is okay, carbon dioxide treatment chill. Okay, then here we have this carbon dioxide. Then here we do analysis of variance. Okay, here there is error plant divided by concentration just now, and this is we want to see the factor for concentration type and these two relation. Okay, so and we call back the function that we defined just now, the V1, V1. Okay, let us run it. And this is the summary from the for the analysis of variance. Okay, we can see here error plan, error plan interaction with concentration, and this is within. Okay, now what can we see from here? Okay, from here we can see that this is for the type. Okay, there is significant result, which is we can see that there are different type give the carbon dioxide uptake. Some are there are factor that this type give to the carbon dioxide uptake, and for the concentration and relation between concentration type also it give the significant result. Okay, because of we look at the p value that we get here is less than 0.001 because in terms of their star there. Okay, it less than 0.01. Okay, then also for this within the group, which is okay, we for the this residual there are no p value here, but we can see the interaction. Okay, how can we see this is the data carbon dioxide. Okay, which means we have the concentration, and this is the carbon dioxide uptake that we get from this concentration. And here we want to see the interaction between Quebec and Mississippi. Here, how can we see the interaction between the two places? Okay, and this is the graph. And just now all the concentration main effect and the type X concentration interaction are all significant at 0.01 level. The interaction is plotted via, okay, this is by via interaction dot plot, and in order to demonstrate a different presentation of interaction, okay, if you want to see the different, we can use also box plot. Okay, this is the box plot. Okay, you can see here from the box plot here, Quebec, and this is the different level, which is 95, 175 for the two different place, and this is also 250 from the two different place. We have just now how many level? 1, 2, 3, 4, 5, 6, 7 level. Okay, and from this idea graph, you can see that there are greater carbon dioxide uptake in the plant from Quebec compared to the Mississippi. Okay, this is Quebec. In the level 95, we can see it more from the Mississippi. It goes, it get the same result for the other level also. Okay. The difference is more pronounced at the higher ambient carbon dioxide concentration. Okay. Can see that if the level is going to the difference will be more higher when the level we increase the level, and the difference we get here is bigger than the lowest level. Okay, and you note that here the data set that you can work typically wide format where available and raw and observation. Okay, and there are many approaches to mixed model design here. Okay, then here we go for the MANOVA. So that that's all the term MANOVA and ANCOVA, but not to worry about that because we already use the tool R to know the uh then significant to the our dependent variable that we study based on the p-value that we get. Okay, now we are going to the slide again. If you have question, you may ask. And I reserve some example at the last of this class, at the end of this class. Okay, this is just now. We can conclude that the greater carbon dioxide uptake in the plant from Quebec compared to the Mississippi. And here multivariate analysis and multivariate analysis of variance. Okay, if there are more than one dependent outcome, we not focus on one dependent. You can test them simultaneously using multivariate analysis of variance. We have more than one dependent. Previously, in our formula, we only have like length. This is the tooth length. Then we we focus on their factor on gestation time, uh, uh, multiply by some factor there. But here the dependent here is only the length of tooth rows. Okay, but here for the multivariate, it is more than one dependent that we want to see the that we want to test them simultaneously, and we use this MANOVA. Okay, the following example is based on US serial data set in the mass package. In this package, it already have this data set, so no need to call this data. Okay, and this data come from this researcher, Venable and Ripley. In this example, we are interested in whether the calorie, fat, and sugar content of US cereal vary by store shelf, where 1 is the bottom shelf, 2 is the middle shelf, and 3 is the top shelf. Okay. We want to study. Is there any difference between these from their location of shelf? Okay. Then calories, fat, and sugar are the dependent variable. Okay, this is the 3 dependent variable that we have. And the shelf is the independent variable, which is 1 is the bottom shelf, 2 is the middle shelf, and 3 is the top shelf. Okay, then we do the MANOVA now in R. Okay, here. We call library mask because this US serial dataset in this library. Okay, after we call this library, we attach the dataset, and here here the C-bind function to form a matrix of 3 dependent. Okay, because of we have dependent variable, then we have to use matrix to represent this this dependent variable. Okay, so that's why we use C-bind here, because of our data is not one which is X, Y, but we have in a matrix these 3 type based on different level. Okay, and this is the C-bind calorie, fat, and sugar. Then from this we can see this data, how it's look like as serial. Okay, now we can see this data set which is in a matrix. Okay, okay, this is the real data set, which is it contain this thing, and this is in the column. Okay. Then for this head US serial, we can see only six, first six, which is okay. This is the first six. You can see in this data. MFR, calorie, protein, fat, sodium, fiber, carbo, sugar, and this is the shaft just now that we mentioned, and also have potassium and vitamin. But here we only want to focus on calorie, fat, and sugar. Because of this one, we define it by using this parameter only. Okay, then we want to get aggregate in terms of mean. Okay, can see this aggregate. Okay, now we have different calories, different fat and sugar on different shaft, which is bottom, intermediate and upper level just now. And COV is function provide the variance and covariance across serial. Okay, let's see what does this COV give to us. Okay, calories, fat, sugar for this. Okay, this is function provide variance and covariance across serial. Okay, so calories versus fat, fat versus calorie. Okay, then in MANOVA, provide the multivariate test of group difference. Okay, the significant F value here indicate that three groups differ on the set of nutritional measure. Okay, then we can see what does this MANOVA, because we have the more than one dependent variable, so we use MANOVA. That's why we have to know the term that I mentioned in the last meeting. Here we fit the MANOVA, and we can see the summary of this MANOVA. Okay, now we can see in terms of shaft here, we can see it is significantly different. Okay, because the trigger differ on the set of nutritional measurement here. You can see it is less than p-value. Okay, because the multivariate test is significant, you can use the summary.AOV function to obtain the univariate one-way ANOVA. Okay, here you can, if you want to see one by one, just now we can, this is by three dependent variable. If you want to see the one by one summary, you can call. Okay, now we can see for the shelf here, response for calories, this is the response for fat, and this is the response for sugar. Just now we recall back that our dependent variable is calorie, fat, and sugar. We can see that in these three dependent variable, we get the significant result. So Richard has known here. Okay, the three group differ on national measure considered separately. Finally, you can use the mean comparison procedure such as Tukey HSD to determine which shaft differ from each other for each of three dependent variable. Okay, so you can use Tukey HSD to see the different for the shaft. Okay, now we are going to test assumption for this MANOVA. We want to use, we are going to test. Okay, the two assumptions underlying one-way MANOVA are multivariate normality and homogeneity of variant covariant matrices. Okay, the first assumption, okay, let's see our, this is The first assumption states that the vector of dependent variable jointly follow a multivariate normal distribution. You can use the QQ plot to assess this assumption. Okay, this is the theory, which is if you have P times 1 multivariate normal random vector X, which mean mu and covariant matrix, then the squared Mahalanobis distance between X and mu is chi square distributed with P degree of freedom. Okay, then in this QQ plot graph, the quantile of chi-square distribution for the sample against the Mahalanobis t-squared values to the degree that the point fall along a line with slope 1 and intercept 0. That's evident that the data is multivariate normal. Okay, now, if the data follow a multivariate normal distribution, then point will fall on the line. Then we use this function allow you to interactively identify point in the graph. Okay, here the data set of appear to violate multivariate normality primarily due to the observation of VTs of honeycomb and VTs. Okay, this is okay, let's just do the QQ plot in R. Okay, here. Okay, we want to create a plot there. Then n row and column y, this is covariant just now. And this is the Mahalanobis distance. And this is the coordinate that you can see. For this, okay, AB line 0, run this first and identify. Okay, we want to identify the, okay, this is where we identify this. Okay, then from this, okay, what the theory said just now. Okay, if the data follow a multivariate normal distribution, then the point will fall on the line. Okay, there is point fall on the line. Then here the data set appear to violate multivariate normality. You may want to detect these two cases and rerun the analysis. Okay, now here, okay, the homogeneity of covariance matrix assumption require that the covariant matrix for each group are equal. Okay, the assumption is equally evaluated with a box M test. Okay, R doesn't include the box M test, but here we can see there's one point on the line as well as this point. Okay, this, okay. But here, we can see, is there any multivariate outlier using AQ plot? If you want to look at the outlier, if there is outlier here, we may use this. If we want to focus on the outlier, we have to use the library outlier, then AQ plot. And there is for the first, second, or first component, function total. Okay, now this is the graph of outlier then. And this is for order square robust distance, and you can see here the outlier based on 97.5 quantile, which is okay, there is outlier there. Okay, this is outlier based on adjusted quantile. Okay, we find the outlier here from his graph. Okay, then we can see the outlier there. Right. Okay, error object outlier not found. you can so there is the code. Okay, there is no error object. There is no outlier here. Because of okay, this is 97.5 quantile and this is adjusted quantile and this is the the first result just now. This is adjusted quantile, and if we sum it in a same graph for the uh, 97.5 quantile, it is here, and this is the adjusted quantile. We make it more to the right. Okay. And for the this is the homogeneity of variant covariant matrix, and unfortunately the test is sensitive to violation of normality, leading to the rejection in most typical case. This means that we don't yet have a good working method for evaluating this important assumption. Okay, so not yet available in R. Okay, now we can, this is the outlier that we used just now by using MV outlier. And this is the robust MANOVA. In this robust MANOVA, if the assumption of multivariate normality or homogeneity of covariance matrix are untenable, or if you are concerned about multivariate outlier, you may want to consider using a robust or non-parametric version of MANOVA test instead. Okay, this is a function for a robust version of one-way MANOVA by using this function. And this is Adonis function is in the vacant package can provide the equivalent of non-parametric MANOVA. Okay, this is listing in 9.1. Okay, from this function to our example, and we can get this for robust MANOVA. Okay, then if you want to run it in R, okay, this is the code for robust MANOVA, which is first we have to install package rrconf. If you already have that package, you just call the library. Okay, I already have that particular package. Then here, rig.test function just now. Okay, from this rig.test, we can, okay, it's still running here. See the result. After this, we can see robust one-way MANOVA. Okay, waiting for the R complete running this function. What we can conclude from the table. Take some time. Are you good? Are you with me? Okay, this is the table that we obtain after we run with.test function. Okay, now we can see from this result, you can see that a robust test that insensitive to both outlier and violation of MANOVA assumption. Okay, still indicate that serial on the top, middle and bottom shelf differ in the nutritional profile. Okay, so it is differ from the, okay, this is the sample estimate, and this is the p-value. It indicate that the cereal on the different level differ in their nutritional profile. Okay, and ANOVA as a regression here. We want to use library multi-comparison. Okay, here In section 9.2, we noted that ANOVA and recreation are both special case of the same linear model. And this, we are using this function to analyze this design. However, in order to understand the output, you need to understand how R deal with categorical variable when fitting model. Consider the one-way ANOVA problem, which compared the impact of 5-cholesterol reducing drug regimen, the previous case. Okay, how can we compare? If we have multi component that we want to compare, you have to use Malcolm package. Okay, now here, library Malcolm, we run it. Okay, and here is the level in terms of their TRT. Okay, because I'm highlighting the dollar sign just now. Okay, this is level for the in the cholesterol, which is 1 time, 2 time, 4 time drug D and drug E. This is the example that we ran last week. Okay, now we want to see the response of TRT in this cholesterol data in their analysis of variance. Okay, here the summary of fit. Okay, we can see it is significantly different, and when we call the cholesterol here, we want to see the cholesterol. Okay, this is the cholesterol data set. Okay, this is TRT, how they consume, which is 1 time, 2 time, and different drug that they give. And this is their response. And by using, we can also test the response by using linear model. Here we use linear model. Okay, we run it. Then we can see summary of linear model. Okay, in terms of linear model, we can obtain this kind of summary. Okay, this is TRT 2 time, TRT 4 time, and TRT drug D. Okay. Okay, and here we can see that we are what we are looking here. Okay, because of linear model, we require numeric predictor when the LM function encounter an error, it replaces the factor with a set of numeric variable representing contrast among the level. Okay, then if the factor has k level, k minus 1 contrast variable will be created. R provide 5 built-in method for creating this contrast variable. Okay, for this contrast variable, you can see in the table here. This is the contrast variable built in R, which is in terms of helmet, and this is the description. In terms of this is polynomial, which is linear, quadratic, cubic, and so on. And for summary, this is the sum of 0 as called as deviation contrast, and contrast each level with baseline level. Okay, then this is contrast SA. S is the baseline level, is the last level. This produce coefficient similar to the contrast. Use the SAS procedure. Okay, now here, with the treatment contrast, the first level of factor become the reference group and each subsequent level is compared with it. You can see the coding scheme via the contrast function. Okay, in this listing, the variable TRT 2 times represent a contrast between the level 1 time and 2 time. You can see in our R here. We have this kind of the result for this, which is it refer to the first one, and the second one refer to the first one, and the third one will refer to this. This is what the contrast function, the algo for this contrast function. Okay. Similarly, TRT 4 time is contrast between 1 time and 4 time and so on. You can see from the probability value in the output that each drug condition is significantly different from the first time. Okay, you can see in our R here, all the, okay, from the first time it is significant. Okay, this is the first time. Okay, and it's all significant. Okay, now you can change the default contrast used in LM by specifying a contrast option that you want to take. Okay, now here we are using the data cholesterol and the contrast also in this table, which is we want to see the contrast TRT 2 time with TRT 4 time and drug D and drug E here. Okay, finish with this all the information. Now, can we continue? There's about 4 exercise that I want to discuss. Whether you get what is analysis of variance about. Let us do some discussion. Is it okay? Now come to the discussion, because from the previous class only me who going to talk a lot, and here I want to know your understanding about this area. Okay, now uh, before that I stop sharing because I'm still sharing on my R, but here just need to know the brief idea. No need to run it in R, because if we want to run it in R, we have to create this data. But I want to know the idea whether you already understand this analysis of variant or not. Okay, let us stop sharing first. Okay, let's share again our PowerPoint. Okay, in this first example, let us read together. Read it by yourself. Okay, done with the reading. If you're all done, please let me know. Okay, this is the study about, we want to know is there appear to be different in the mean lifetime among the 4 brand of batteries. Does there appear to be different in the mean lifetime among the 4 brand of battery? Okay. this data we have 4 brand A, brand B, brand C, and brand D to be compared by testing each brand in 5 flash light. Okay, it put into the 5 brand A into 5 flashlight, brand B into 5 flashlight. Okay, then same goes to C and D. Okay, then we have 20 flashlight are randomly selected and divided randomly into 4 groups. Okay, then each group of flashlight use a different brand of battery. The lifetime of the batteries to be nearest hour. This represent the nearest hour that it take. Okay, from brand A, brand B, brand C, and brand D. Okay, then preliminary data analysis indicate that the independent sample come from the normal population with the with equal standard deviation. Okay, now the thing that they give us information is at the significant level, which is 0.05. 5% is equal to 0.05 significant level. Does they appear to be different in mean lifetime among the 4 brand of battery? Okay, now the significant level here is 0.05. And here we notice that what is our hash null? Okay, you already learned about what is our hash null. Okay, this is the thing that we want to see, which is there a difference in mean lifetime? Okay, hash null is there is no difference, which is all the battery have the same lifetime. Okay, are you good, Safion? And for the alternative one, not all same, which is there is different. Okay, now this is our significant level. Okay, now if we do this in R, then we get our p-value. We get our p-value. For example, our p-value is 0.15. This is our p-value that we get from R. If we create this data, if we create this table, then we find their fit. For example, AOV in the kurungan, which is the formula, we get the p-value is 0.15. Okay, how can we conclude about this? It will fail to, is it? How can we conclude if we get p-value 0.15? Just now the significant level, we must get less than this because this is the significant level that they state. But we get this, meaning that our p-value is greater than our that stated here, right? Which is here we can conclude that there is not enough evidence to conclude that which is we can't get the conclusion that we don't have enough evidence to conclude that the mean lifetime of the brand of battery are differ, which is we can't conclude that because we get the value is more than 0.005 here. Are you good? Fail to reject. Yes, correct. Siapa tadi yang cakap dekat chat? Iza. Correct, Iza. Fail to reject hash null. Don't reject. Why you don't reject?
Yalah, fail to reject. Same lah. Don't
Same lah kan? Fail to reject, don't reject, fail to reject. Betul lah. Don't reject. Okay, that is fail to reject lah. So that we can conclude that there's appear different in the lifetime of who ran out battery. We can conclude that we can conclude by using all the information. We only have this p-value by comparing this to the significant level, so that we can conclude that there is not enough evidence to conclude mean lifetime of the brand battery is differ from each other. Okay, then we go for the next example. For example, here, we have different group of Caesarean patient, which is a study of effect of different type of anesthesia on the length of post-operative hospital stay yield the following for Caesarean patient, which is group A given a epidural MS, and B was given an epidural, C was given a spinal, and this group D given the anesthesia. Okay, then the data present below. In general, anesthetic is considered to be the most dangerous. Okay, the spinal somewhat less so, and the epidural even less, with MS addition providing additional safety. And note that the data in the form of distribution of each group. Okay, this is unbalanced data, right? We can see here, which is 6% received from group A, and it's only stay for 3 days. Okay, and this is for 14 patient. And okay, here what we are going to study here, we want to know the a study of effect of different type of anesthesia on the length of post-operative hospital stay. Okay, now here, is there any mention about significant what we call significant level in this study? There is no mention, right? So how can we conclude? Usually we are only use 0.05 or we use 0.01. Okay, now. Okay. But if we want to use 0.0, our significant level is, for this case, for example, we want to use 0.001. Okay, now here, for the H-null hypothesis, there are no different. For the H-null hypothesis, there are no different, which is same effect. And for the H alternative is, there is at least one different, right? Okay, this is the H hypothesis for this study. And if we get after we do it in, we create this table and we find the, for example, we want to know the effect. Okay, here we name it as, we run it in R and we name it as effect, and this is AOV, and put our formula there, which is effect. For example, the relation between effect to the length of post-operative hospital, which is, we want to know the different type, which is, for example, we name it as a type of what we call anesthesia that they get by the length of the post. Okay, then after we get this, for example, our R give the result p value is just now our significant level is 0.01. And if we get this p-value after we are doing the R code, then we get this p-value 0.00013. This is less than alpha. Then what we can conclude for this? We have to reject null hypothesis. Then what can we conclude? Because it is less than alpha, then the conclusion that we may get is there exists enough evidence to conclude that there is an effect due to the anesthesia type. So there is effect due to the anesthesia type. Okay. Are you good? This is second example. And we go for the next example. Okay, here. They have already mentioned the significant level. Then this is the 3 set of 5 mice were randomly selected to place in standard maze, but with different color though. Okay, we put mice in the maze and with the different color. The response is in the time required to complete the maze as seen below. Perform the appropriate analysis to test if there is effect due to the color. Okay, if we use our code in R, and by using we want to test whether our p-value is greater or less of this, then if we get our p-value is less than alpha, which is our p-value is less than alpha, what we can conclude? Okay, there is significant, there is what we call, there is effect due to the door color for the mice, right? Okay, factor, color factor will affect which mice will do it in the shortest time. Okay. Okay. And this is the last one, I think. This is the last one. Okay, this is question. You may read the question. Okay. There is study of firefighter in the large urban area center on the physical fitness of engineer employed by fire department. To measure the fitness of physical therapy sample, 5 engineers each with 5, 10, 15 and 20 years of experience in the department. Okay, this is different experience that they have. Then they record the push-up at each person in 60 seconds. Okay, in 60 seconds, the results are listed below. Okay, there is how many person there? Perform an analysis of very different physical fitness of engineer by time with department. Group we have 5, 10, 15 and 20 people here, right? We want to know, is there a difference in the physical fitness of engineer by time with department group? Okay, so this is the significant level. And if we get it less than alpha, what can we conclude? There is difference in the physical fitness of engineer by time with the department group. That's what we can conclude. Okay. This is example. I just put this example so that we know what can we conclude from the result that we get in R. Okay. Just now you can see in R the way that we find our interaction in each factor. We use interaction dot plot, and if we want to find analysis of variance, we use AOV code. And if we want to find, if we have a lot of more than one dependent variable, like just now we consider the dependent as calorie, sugar, and another one where it is greater than one dependent variable. So we find it by using MANOVA function. And if we want to look at each of dependent variable, we can use the last one just now. It also AOV, which is summary of AOV in the MANOVA test. Okay, that's how we use R to help us to analyze our factor of each factor in our dependent variable that we want to evaluate. Okay, you put now in 9:90 p.m. 19 p.m. Is there any question from you? Stop sharing. Okay, my suggestion is please look at the book that I attached in this folder in my ULearn for analysis of variance, because it gives you well explanation, and in this course we don't have to calculate it manually. If you have question, maybe for the test, in my part I will not involve the calculation part, but in terms of answer, if I give this table, how can you conclude? That's in the last lecture just now. I give you example, then I give you one table. How can you conclude? And from this table, how can we get the factor from this table? What formula that we going to use? For example, the formula I already teach you in the first few slides in the beginning, which is the last week. This is also important. The slide here, the slide number about the formula. How can you create a formula? This is a formula. If you want to find if we have a lot of column, but we want to focus on 3 column, but interaction from that particular 3 column, what formula that we are going to use? Some kind of question like that, because this is the explanation how can we use. And you can see also in R, when you use this kind of formula, what you are going to have in the answer. For example, if I share back my R, for example here, I put formula like can see my I, right? Okay, for example here, AOV, where is AOV? This is formula. This is one type of formula. From this type of formula, you only get this gestation time and dose only. But if we put plus, if we replace plus with time, what factor, what result we can have? Can see if we change it into plus, what table that we can have. For example, just now we use plus. For example, here's called concentration times start, and there's another, okay, gestation time that plus dose, and from here we can see that we can get this factor. Another one is dose factor, another one is gestation time, relation with the tools. It's all already explained in this table, symbol and formula in R. Okay, this is two-way factorial there. And how can we represent? If we have covariance there, we will put covariance first, then all the factor at the back. That's all the important thing that you have to know. And the most important thing is how to create a hypothesis from the question. And if we get this kind of table of solution, what conclusion that we can get? That's the most important thing. Okay, no need to do calculation for my case in the midterm. But in the lab test or ANOVA, all calculation or already R will do all the calculation for the question that I give in analysis of variance. If you have question for the lab assessment for analysis of variance, for my part, also in the cleaning data, you may ask me, you may text me in a WhatsApp, then I will, or you're not clear about that particular type of what the question one, you may ask me also. Okay. That's all from me, and hopefully you will success in this MTDS with flying colors. And after this you will see Dr. Fauzia for the next session. And up beside we have lab, we also have the analysis of variance in midterm test. At the end of this course, we have midterm test, and analysis variance will cover on the midterm test. Okay, is there any question before we stop?
Dr. Durrani,
Ah,
I see the slide is not updated yet. Could you please upload the slide? And also the 4 examples. Could you please also share the answer?
Okay, but you don't have to confuse with the answer, because this example I take it from the internet. They calculate it manually, but you can use R to get the p-value. Don't take that part so seriously, but how to conclude that result is most important. Okay, Sim. I'll put the recent slide after this.
Okay. But how about the midterm test? Is it a similar question like the example?
Actually I'm not draft it yet, but I'm thinking about like example, which is if there is one question, I already put the result from R, then you have to conclude something. Or maybe there is a formula that you have to create. How can we get this significant from the factor? I give 3 factor. I want this main factor, and I want the relation between these 3 factor. How can we create a formula from that? That's kind of question like that, something like that.
Okay, so we are requested to write the outcode, but we do not need like few example. Probably there are 2 questions. The first question is you provide us the outcode and then the table and also the result, and we are asked to provide the analysis. Okay. Okay. So the second questions will be probably like you provide us the ID and also the IV and also the DV. So we are requested to write the outcode, but we do not need to provide the answer, right? Okay.
Okay. Okay. If there is one question in the chat here, if the question doesn't mention the alpha significant value, okay. Aiman, if the question doesn't mention to you, but you have to be determined there. You for example, here we decide to make 0.001 as a significant level. So from the table result that they gave us, we can conclude that something you have to determine first what is significant level. So between 0.05 and 0.01. Correct, Aiman. Then step by step, what is it, Iza? The step by step of code or what? You want to mention about, we want to state the
The answer. You see the answer, we just write the answer or the result hypothesis step by step.
If they, step by step.
Just write the answer. Dr. said there's a step by step. He give us the example what to do step by step.
Oh, okay. Because in the set topic, there is calculation step by step, right? Is that?
Yes, correct.
Yeah,
It is step by step. So
Ah,
it is basically 5 steps. So
Uh-huh.
the question is, if this we need to provide the step by step, or Dr. Zurani, could you please share with us the step by step?
Okay. For me, actually, if I do the question, I will guide you. First, okay, from this kind of question, please state 2 hypotheses that you can make. Then you answer. For example, B, that's the A, for example lah. And B, from this question, what is the significant, is there any significant level stated, or you have to determine, and please write. Then from the table result, for example lah, I don't have the question yet. From the table result, there is for example, 2 factor that we analyze. Please create formula by using the output for something like that. Then you can answer one by one like that. Simple line. Just answer A, B, C guided question for me. I'm not simply just write your answer anything, but I will guide you. A, B, C. You can answer A, B, C, D until finish with the conclusion. Same like my question in the lab. I guide for the analysis of variance. You may see the lab assessment for analysis of variance. Just answer the A, B, C that I put there. Okay. Okay. Then if you have any question regarding these 2 topics that I teach, you may ask me also after this. You may text me. Okay. Good luck. So can we
Okay,
start?
thank you, Dr. Zurani.
Thank you.
Bye.
Bye.